Our Sun is almost a perfect circle. In fact, its polar diameter is only 10 kilometers difference from its equatorial diameter. It's easy for astronomers to forget the brightest star in our sky. Hi everyone, Vega here, and in today's video, full-length documentary, we're going to be looking at the brightest star of all in our skies, the Sun. So let's get to it. One of mankind's greatest achievements was when the Voyager probe was turned around and a family portrait was shown of all the beautiful planets in our solar system. Carl Sagan talked about a little blue dot, where everything in human history, every single person that had ever lived existed on that one pixel in the huge cosmos surrounding us. Now we all thought it was fascinating, but maybe we could go one better, because although we can't see the Earth from much further away, the Sun remains bright in the sky for many light years. But how many light years, you might ask? What would the Sun look like from other stars and how bright would it be? In this video, I'm hoping to show you just how insignificant we really are, and just how small and insignificant in the great scheme of things our Sun really is. First, let's look at the local stars in our area. We know Proxima Centauri in the Alpha Centauri system, Barnard's star Sirius and Tau Cetus. In the Alpha Centauri system, the Sun shines brightly in the sky at plus 0.37 apparent magnitude. Now you may have already noticed that the Sun, even in the skies of our nearest companions, is not the brightest star, other than the Alpha Centauri stars themselves. The dog star of Sirius, brightest star in our skies, remains the brightest star in the Alpha Centauri skies also. So what about Sirius itself? Imagine we were landing on a planet in a strange saucer-like UFO spacecraft in orbit around the A-class main sequence star of Sirius A. From this Alpha Canis Majoris system, some 8.6 light years from our Earth, the Sun would shine at fairly bright in the sky at plus 1.84 apparent magnitudes, but it's beginning to pale now into insignificance, with many other stars now outshining it, including the tiny white dwarf companion of the huge star, a star known as Sirius B, or the Pup, which would remain fairly bright in the skies of a planet orbiting Sirius A, despite its tiny frame. At what we call absolute magnitude, the Sun is relatively bright at plus 4.86, so bright in fact that it outshines 95% of other stars, but again, most other stars in our universe are tiny red dwarfs. So you might ask then, what are the most massive stars within 20 light years? Here we see a table, and we note that the Sun does hold its own at 6th most massive. Only 5 stars are actually heavier. Of course, the large Sirius A and Altair are very similar A-type stars, followed by the F-class white-yellow star of Procyon A, Rudracontaurus, and interestingly, even Sirius B the Pup is actually more massive. But after that, some of the more famous stars remaining on the list, you may know Ptolemy, also known of course as Alpha Centauri B, and the beautiful Tau Cetus, right at the bottom of the list now, has a mass just 0.78 solar masses, and it only just makes it onto the list at all. So let's go a bit further out. The Sun itself has a 28-day day, or in other words, a counterclockwise nature. It turns once on its axis every 28 days. The Sun is a very slow turning star, with most other stars rotating quicker. Here we see a graphic of the giant star Pollux, which is the closest giant star to the Sun at 33.7 light years. In the skies of Beta Geminorum, we see Castor, another star mentioned after Pollux, which becomes the brightest star other than Pollux itself in the skies, at minus 1.84 apparent magnitude. We see orbiting Pollux, the theorized Pollux B planet, formerly named as Thestias, also brighter than our own Sun, reflecting the light of the giant yellow star. The Sun is now plus 4.81 apparent magnitude, and you can begin to see how insignificant it is. We remember that at just 33 light years away, Pollux is the largest star in our local area. The Sun fuses 600 million tons of hydrogen every second, and for reference that's the same amount of matter as the Great Pyramid of Egypt. Despite that, we can see now in the skies of the unknown star 18 Puppis, an F-class star some 73.3 light years away, that it has a bright red dwarf in orbit around it. The Sun's apparent magnitude is now plus 6.5, and this is significant because it's the magnitude where the Sun ceases to be bright enough to be seen with the naked eye. The naked eye struggles to see anything over this apparent magnitude. So really, this is where our yellow dot disappears, at 73.3 light years. That's where our visible influence, if we were looking back at ourselves, would disappear completely forever. It is thought that the Sun was formed by nearby supernovae shockwaves, and indeed we have identified 2 solar siblings. The strangely named HD 162826 is 110 light-years distance, and we will look closer at these stars in the next part of this documentary. 99% of the Sun's energy is actually produced in its core, and the density in its core is 50 grams per centimetre squared, and that's actually 150 times water. The Sun's core reaches around 20 to 25% of its total radius, and when we think of heavy dense objects, we often think of white dwarfs or perhaps neutron stars, but the core density of our own G-class star is also extremely dense. Imagine trying to lift a glass of water that weighed 150 times more than usual. Quite fascinating to consider. The next significant landmark in our local area of stars is perhaps the red supergiant of Betelgeuse, at around 642 light-years away. The Sun, as we know, has long since disappeared from view, and if you had a telescope on a planet in orbit around the huge supergiant star, the Sun would appear at plus 11.2 magnitude. For your own reference, this is roughly the same brightness as the star Proxima Centauri as seen from Earth, and as we now know, this is completely impossible to see with the naked eye and would need quite powerful telescopes to see. Interestingly, it is also equivalent to the brightness of Mars' tiny moon Phobos as seen from planet Earth. As we carry on, we remember that our own yellow dot has long since disappeared from our naked eye view, but what would we see with powerful telescopes? The next graphic is quite difficult to explain. The star V762 Cassiopeia has some fame as it's the most distant star known that remains visible to the naked eye. So with an apparent magnitude of plus 6.5, V762 Cassiopeia is thought to be, well, the question is how far is it? I've done some research. Some seem to think it's 2,764 light-years away, whereas others debate whether it's 16,310. Either way, V762 is a gigantic star in the orders of hypergiants, like UY Scuti or VY Canis Majoris, and as things stand it is the furthest away star that can be seen with the naked eye, despite its strange distance irregularities. Now you might well ask then, what would anyone in orbit around this star see if they had to look back over the vast distance to our own Sun? Its apparent magnitude, depending on the distance, would vary between plus 14 or even plus 18 apparent magnitudes. For reference, this is roughly the same as the planet Pluto from planet Earth at plus 14, or its strange moon Charon at plus 16 apparent magnitude. That hopefully gives you some reference just how dim the Sun would be at this distance. Before we finish this first part of the documentary, consider subscribing if you haven't already, and it would mean a lot to me if you could add a like to the video, as it helps with the YouTube algorithm. As we continue the documentary about our own beautiful star, we will talk about solar siblings and stars that we may think of as our twins of our own star, born in the same time and place. As a final note from this part, we might think how bright would our star be if we were to look up from the Andromeda Galaxy, the next large galaxy to us at some 2.5 million light-years distance. The answer is our Sun would shine at some plus 29 apparent magnitudes, completely invisible to even the most powerful binoculars and most telescopes. For reference, that would be roughly the same brightness as the asteroid 2003 BH91, which is a Kuiper Belt object seen by the Hubble Space Telescope in 2003. At 6.4 billion or 42.5 astronomical units, it measures just 20 kilometers across and is the dimmest known directly observed asteroid. Indeed, Halley's Comet was also viewed in 2003 when it was 28 astronomical units distance from the Sun, using the ESA's Very Large Telescope, and the total exposure time of 9 hours. It does make me wonder whether there really is a Planet 9 out there. Given that we found such distant tiny objects, I guess we'll just need to keep searching. In this cosmos that we find ourselves in, there are massive, huge distances and vast empty spaces. We see our little yellow dot soon vanishes from view, from even the most local stars in the local area of our own galaxy. It seems we're really so insignificant in terms of a whole galaxy cluster, but I guess we should remember that what remains significant about our star is it has a planet in orbit around it that contains life, which is something that so far in our search we've never found anywhere else in this beautiful universe. Our Sun is actually white and not yellow. Indeed, atmosphere scattering makes it appear yellow at lower altitudes in the sky, but white it remains outside of our atmosphere. We continue our video and now into the second part of this documentary. We're going to be looking at the composition of our beautiful yellow, or should I say white star, and also whether it has solar sisters roaming around somewhere else in the galaxy. So let's continue. The amount of heavy elements in the Sun, like gold or uranium, make it likely a population 1 star, which means it has high metallicity. Indeed, its composition is almost exactly mirroring the exterior universe at roughly 75% hydrogen, 24% helium and 1% oxygen, with a little bit of carbon as well. Isn't that interesting, that the star at the centre of our solar system is an almost exact cross-section of the universe outside? Indeed, also it's not that well known that the Sun emits most of its light in the infrared. In Barnard's Star Planet Update, we talked about how Barnard's star had a bolorimetric luminosity far in excess of its visual light luminosity, and that indeed Barnard's star, while very dim in the visible spectrum, was quite high in the infrared light, and this also applies to our Sun. We talked about the visible distances where we might see the yellow dot disappear, or should I say now white dot, but in fairness it's not completely accurate. Another 50% of our Sun's light is released in the infrared, and as much as 10% in the ultraviolet, as opposed to only 40% in visible light. Unfortunately, at this point it's difficult to deduce exactly where the little infrared dot would disappear. The Sun is slowly heating up as it goes through its lifetime, but there is something that is perhaps not quite as well known that awaits us in our future. As helium builds up in a star that's between 0.8 and 2 solar masses, unfortunately for that star, it's not heavy enough to fuse, and the helium coagulates together as degenerate matter. Now the star continues heating over millions of years, until eventually a triple alpha process is ignited due to the ever-increasing core temperature. It finally enables 3 helium-4 nuclei to fuse together into carbon-12. This happens over just a few seconds or minutes at most, and it's called a helium flash, where the Sun suddenly begins to burn the degenerate helium that it's been stockpiling for millions, sometimes even billions of years. The output of the star suddenly increases from 1 to 100 billion times its normal energy output for those few seconds to minutes, until eventually thermal pressure takes over, allowing a more stable burn. Indeed, this helium flash will release as much as 0.3% of a Type 1 supernova. So in around 1.2 billion years from now, we'd better have our act together, and we'd better watch out, because I can't see this ending well for planet Earth, or indeed any other body in our solar system. Larger stars than the Sun are able to burn the heat more consistently, so this is only an occurrence in G-type, K-type, or perhaps even pushing into the small or lower levels of the F-class main sequence stars. The Sun, or Helios as it's named in Greek, or Sol in Latin, originated from somewhere in the galaxy, and if we can find where it originated from, perhaps we can find the answers to more questions about where life itself originated from. Recently, in 2009, a solar sibling with the unfortunate name of HD 162826 was identified some 110 light-years away from us, with an apparent magnitude of 6.46. Indeed, this star is so faint that it hovers almost above the limit of what we can see with the naked eye view. It lies in the same area of the sky as the beautiful star Vega and the constellation of Lyra. At 15% more massive than the Sun, it's an F85 type star, on the lower end of the F-class, and also has 3% more metals. We think it originated from the same gas cloud or star cluster, indeed stellar nursery. The reason for this is some chemical components within this star, such as yttrium or barium, can be seen in its spectra, and they are almost identical to our Sun. And indeed, if we follow the orbit backwards at HD 162826, it appears to originate from exactly the same spot as we did. The cloud that the Sun formed in was thought not to be so densely packed as to disrupt planetary formation, and so you might wonder if HD 162826 might itself have planets just like our own. The answer is not yet. We haven't found anything to date, and for now we can definitely rule out hot Jupiters. It's thought the habitable zone of this star would support a Mars-like planet in its Goldilocks zone, or even perhaps something slightly further out could be habitable. The Earth may just survive, but it's more likely to turn into a Venus-style hell world. As the chemical components of this star come from exactly the same place that we came from, there is no reason to doubt that its planets could be almost identical in makeup too. Lead researcher Ivan Ramirez thought that it could be so important that in the future, HD 162826 may become the very epicenter of the search for life. Strangely though, and despite its 110 light-years distance, it's still considered to be perhaps very close, and many think it should have dissipated further. Indeed, in the search for planets around the star, Ivan Ramirez continued to state, "We want to know where we were born. If we can figure out in what part of the galaxy the Sun formed, we can constrain conditions on the early solar system. That could help us understand why we are here." There is another star that was also identified known as HD 186302. This second candidate for a solar sibling is a further 184 light years away, and is even more similar to our Sun, as it's thought to be a G3 to 5 main sequence star, almost exactly the same as our Sun, with 0.97 solar masses and 0.95 solar radii. HG 186302's apparent magnitude renders it out of view to the naked eye, but it has a spectrum that's extremely similar to the Sun. It's thought though, however, in a 2019 paper to perhaps this star is not actually a solar sibling, as at first thought, as once its orbit was tracked back, it didn't appear to be following the same path as ourselves, or indeed HG 162826. The search for life in our universe continues. Stars like our Sun, or indeed potentially even better than our star, were created in the same stellar nurseries as our Sun. The interesting thing about these two potential solar siblings is at present they have no name and only seemingly random numbers. But these two stars are made up of exactly the same material as ourselves, our bodies and our planet. Earth's atmosphere and everything in our solar system comes from the same place as those stars. They are exactly the same as us in makeup. Unfortunately though, we won't be visiting them anytime soon, as the distances are just too vast. But maybe one day in the future we'll have identified all the stars that originated with us in the stellar nursery, where human life and everything that comes with it also originated. Spiraling away from each other, each one of our solar sisters, brothers and cousins is now set on its own trajectory in our galaxy. Our Sun has since found other stars to keep it company, Alpha Centauri, Barnard's star and Sirius. But like human life, friends and acquaintances come and go, but family endures. Maybe the search for life will one day reunite us with our celestial family. We'll just have to wait and see. Moving on now, it's fairly common knowledge that the Sun will heat up and eventually turn into a red giant before puffing out its outer shells, left to slowly fade away over trillions of years as a white dwarf. But sometimes we don't focus on the details of this process, and what would it be like living around the star that's the centre of our solar system? As we continue in today's video, we enter the third chapter of our full-length Sun documentary, and now we're going to change tack and begin looking into the future of our beautiful star. 10,000 years from now, it's thought that the red supergiant star Antares will go supernova. What a view it will be! It's likely by then humans will still be around by then to see it, or at least humans in some form or another. In 10,000 years we may even have spread out to our local cluster of stars by then. We'll be able to see the Antares supernova from more than one vantage point. Meanwhile, back on Earth, assuming we've not destroyed our own planet, things should be ticking over pretty straightforwardly, and similar to the way that they have been for hundreds of millions of years now. But slowly and surely over the vastness of time, the Sun will heat up, and what will we see when that happens? In 36,000 years from now, interestingly, the Alpha Centauri system continues to move closer to us and reaches perihelion, if indeed that's the right term, or closest approach, of around 3 light years. But just for a brief passage, the tiny red dwarf star of Ross 248 will make an approach that's even closer. And indeed, the Voyager 1 probe is heading in that direction roughly also, and will make its closest approach in around 40,000 years at 1.7 light years. In a recent podcast I heard, Dr. Benjamin Zuckerman explained the idea that we can leapfrog on stars across the universe. While it may not be as faster than light travel, it could be a way of spawning the universe. So the Alpha Centauri system, along with Ross 248, and as you can see on this graphic, maybe Gliese 445, could also be a stepping stone before they set off back on their way into oblivion and outside of our sphere of influence. Interestingly as well on this graphic, you can see that the bright star Sirius is also just about approaching us, and it will also make a closest approach in around 70,000 years time, and will therefore remain the brightest star in the sky after the Sun for the foreseeable future. As we advance, some 250 million years from now, the Earth's crust will have evolved, so a new supercontinent, sometimes thought to be called Amasya or Nova Pangaea, will have formed. But by then the Sun will slowly have increased in heat and global temperatures will slowly and surely begin to rise. In 600 million years time from now, the Venus crust will have recycled itself via subduction and volcanism. Will we be living on Venus by then? Who knows? It's going to be interesting to find out, isn't it? From now on, the scorched Earth scenario gathers pace. Here we see a graphic of what might exist in 700 million years time from now. Temperatures now mean that the human survival would have long since passed. As we approach 1.1 billion years, the Sun will be 10% more luminous than it is now, and Earth's temperature will have risen to a 47 degrees Celsius on average. This means that much of the Earth's oceans will begin the process of disappearing, leaving only the remaining oceans around the poles. The once mighty Pacific and Atlantic Oceans will be left just in localized pools of water, just like swamps in the Everglades today. With each passing degree of heating, life will be less able to survive our sweltering planet. At 1.2 billion years, most plant life and animal life will have now become extinct. Yet for now, the Sun remains as a G-class, unremarkable yellow dwarf when we're seen from outside our own solar system. The cataclysmic destruction goes by unnoticed, at least for now. Sun approaches the luminosity of Alpha Centauri A, also known of course as Rigil Kentaurus. In 2 billion years, in the Earth's skies, we will see the beautiful collision from our solar system of the Andromeda Galaxy and the Milky Way. Now, some might think such a collision could mean that the Sun's at risk of being hit by another star, but the distances in between stars are so vast, in fact, that the possible chances of the Sun even being influenced by, let alone hitting another star, remain remarkably small. So more than likely the solar system will still be in existence by then. But back on Earth, life will have been completely extinguished. The ever-increasing burning heat of our Sun turns our once green and pleasant world into a Venus-like hell planet. At 3.6 billion years, the moon Triton finally forms within the Roche limit of Neptune. It breaks up, leaving the blue planet with a beautiful ring system, and meanwhile our Sun reaches its final billion years of existence on the main sequence. Slowly and surely, it grows in size and cools into the red giant that has always been its destiny. Here we see a graphic of the beautiful city of Berlin. Now, in the present day, Alexanderplatz and the beautiful river Spree can be seen. Of course, in 4 to 5 billion years from now, Berlin will have long since disappeared from existence, but let's imagine for the purposes of this video that although humans won't be around to see it, it remained perfectly intact. The next graphic we see what Berlin would have become under the red giant sun. The spray completely evaporated, possibly to be replaced by flows of lava and heated materials. Dominating everything in the sky, it is of course possible that Berlin would not exist at all, as it, alongside the Earth, could have been enveloped by our Sun. We're not exactly sure, but it's more than likely it will envelop Venus and Mercury, and leave Earth to become the first, scorched and burnt planet in the solar system. Finally, after between 500 million and 100 billion years later, the red giant Sun finally runs out of helium, and with nothing left light enough to fuse, the Sun puffs out its outer layers in a final breath of life, to reveal its core, a white dwarf star with no internal heat source, nothing but a remnant of glorious days gone by. The white dwarf Sun from planet Earth would still remain a fairly good light source in our skies, and estimates vary for its luminosity, but a figure somewhere in the middle range might mean it offering a magnitude of around -22, which is roughly equivalent to the current brightness of the Sun at the planet Saturn. The Earth would go from being a heated hell world to a frozen wasteland. Berlin would freeze solid with temperatures in the -200 degrees range, or perhaps even cooler. The future of our Sun is fairly clear. We know where our Sun is headed, and we know what processes it will go through. The question that remains is, will we still be here to see it? Will our AI overlords have taken over by then, and will our ancestors have digitized themselves and beamed themselves out across the vastness of the universe? Our Sun will remain as a white dwarf for possibly even trillions of years, cooling down, forever circling its new Milk-Dromedar galaxy home. Maybe by then the human race will have evolved, and the Sun and its beautiful planets will just remain as history, like in a children's story that we all remember and look back on with warmth and pleasant memories, but long since having lost relevance to future civilizations in our colonized universe. Thanks for watching, and consider subscribing if you haven't already. If you'd like to support the channel further, you could consider buying me a coffee, and I'll link this in the description. Thanks to those of you who have already done so, and if you have any videos or subjects you'd like to see brought to life, don't forget to let me know in the comments below, and it could just be your idea next week that shows up. Take good care of yourself and look after your friends and family well, and I'll see you on the next one.